This is our friend, the nitrogen and the oxygen, getting into equilibrium with nitrogen monoxide. It says here the delta H is a positive number. So this is an endothermic reaction. You're going to have to put energy into it to make it happen. So if you have to put energy into it to make it happen, that means you're going to want to think of it as being this shape. The difference between this level and this level is the 181 kilojoules. That would be per mole. Per mole of what? Per mole of nitrogen or per mole of oxygen. Clearly, you're creating 2 moles of this. When they write these sorts of things, they mean for the reaction as written. And so you would be able to say this number of kilojoules per 1 mole of nitrogen gas or per 1 mole of oxygen gas, and you'd end up saying that this was per 2 moles of nitrogen monoxide. It means that I have nitrogen and oxygen and heat. We'll go this way. I am raising the temperature myself on the outside. So I am applying heat. It is absorbing it and becoming these 2 things that have more potential energy than these guys did. So now the energy is contained in the bonds. Supplying heat, I'm pushing it this way. So that means I can expect the concentration of nitrogen monoxide to go up. I can expect the amount of nitrogen and the amount of oxygen to both go down. That means K must be going up, because remember, K is the products over the reactants, and the number for the products is going up, the number for the reactants is going down. So I'm increasing the numerator and decreasing the denominator, both of which will make K want to go up. So I know that this is going to change K to positive. This is a summary. If I have an exothermic reaction, so if I had an endothermic one, I have to think backwards. Exothermic, so heat is a product. 2A in equilibrium with B. What are the stresses? I could add A. If I'm adding A, it's going to say, oh, no, A is too high, and so it's going to make more B. If I remove A, oh, it's too low. I'm going to come back and produce more of A. If I add B, whoop, B is now too high. We're going to go this way. If I remove B, oh, B is now too low. Oh, let's make some more. Increase the pressure. These are gases. 2 gases on this side, 1 gas on this side. So if I am increasing the pressure, it's like, oh, I don't want the pressure to be that high. I'm going to go this way. If I'm going to decrease the pressure, then it's like, oh, pressure's too low. How can I make it higher? We'll make more A's and get rid of some B's. You'll end up with more pressure that way. And then increase the temperature by adding energy. This is the one where you have to think backwards. Which way is this? This is exothermic. Heat is a product. I'm increasing this. Ooh, so I'm increasing a product. I'm going to switch it to the left then. Decrease the temperature by removing energy. Oh, I got rid of some of the product. I'm going to go this way. So we have control of these things. And chemical engineers spend a lot of time controlling pressure and temperature, as well as just what are the things that are in the reaction mixture.